Hi, I'm Liz Nedden. Let's have a look at our binomial distribution. So a binomial distribution has two parameters. It has our sample size n, or a number of trials, and it has the probability of success, which we sometimes call p, or sometimes we use the symbol pi to denote that. So what I want to do is just have a little look at what the difference these parameters, what effect that these parameters have. So this image that we're seeing now this is showing you if I keep my number of trials fixed at 10, what happens as the probability of success changes. So I've been starting that from probability of 0 all the way through to the probability of 1. So here's the probability of 0, and we can see that the distribution is getting to probability of a half, and probability of success getting closer and closer to 1. So as with the low probabilities, the distribution is left skewed. Middle is about normal, and that's when the probability is higher, it's left skewed. When you've got a low probability, it's right skewed. Middle distribution when you've got a probability of about a half, and left skewed when you've got a probability of around 1. So this is another different image now. This is looking at what happens when my sample size or number of trials change. So I'm keeping my probability fixed, but I'm increasing the number of trials. And so you can see as the number of trials is increased, this distribution is changing. So start off 0, 1, 2, 3, 4, 5, and now the sample size is increasing and that shape changes. So both the number of trials and the probability of success, both of them have an effect on the distribution and therefore the probabilities. So let's have a look at some more information about it. So the distribution for binomial is discrete, so it has to be positive values and integer values. There are only two outcomes, so success and failure. So for example, if I toss a coin, getting a head might be a success, getting a tail might be failure. If, however, I want to take a scenario like rolling a dice, I know normally rolling a dice I'm going to get outcomes 1, 2, 3, 4, 5 and 6. So that doesn't meet the criteria of having two outcomes because there's 6 outcomes here. However, if I group them, I might group them into, say, getting a 6 versus not getting a 6. That then makes it into a binomial distribution with two outcomes, success and failure. Some assumptions that we have is we always assume there must be two outcomes and only two. The probability of success is constant. So if I was tossing a coin, every time that I toss that coin, the probability of getting a head is the same. So that doesn't change. The number of trials is fixed. If I say I'm going to do 10 trials, I need to do 10. And we could see in that little animated image earlier, if I change the number of trials, the shape of my distribution changes completely. And the last one is that events are independent. So each time I toss a coin, that is an independent event. So here we have some formulae, and these are straight from your formula sheet. Now what you'll notice is there's this part here of the formula, nx in brackets. This is what we call matrix form. So this you might be more familiar with it as n choose r. So this is combination form, and we'll go through how to do that on the calculator later. So there's our formula to calculate the probability. To calculate the mean, we do our sample size n times the probability of success, and the standard deviation is the square root of n times the probability times 1 minus the probability. So let's look at this example. So we're told 25% of the bones in our body are in our feet. If 5 of those bones are selected, what is the chance that 3 of them are from our feet? So I can immediately start to recognize this is a binomial distribution because I've got this probability of success of 0.25. If it was a rate, I'd use the Poisson. If it was other information, I would use normal, rectangular or triangular. We're told we got 5 bones chosen at random, so that's our number of trials or our sample size. And we want to find what is the probability of getting 3 of those. So you can see in the picture underneath, this is a picture of the specific distribution here with a p probability of success of 0.25 and a sample or number of trials of 5. And we want to find the probability of getting 3. So that's this one here. That's what we're trying to work out. What's the chance of getting 3 out of the 5? So there are 3 different methods that we can use to calculate this. So we can use the tables, a graphics calculator, or the formula. So let's start by looking at the tables. Now on our tables, you'll notice across this top piece there, that is your probabilities. And in particular, we want a probability of 0.25. And I'll just write this up here to remind us. N is 5 and probability of success is 0.25. So there's our value of 0.25 on the table. Now I'm going to come down the side here, and there's my N value of 5. And my X value, I'm trying to find the probability that X is equal to 3. So I'm going to go along and find where these all meet, and that gives me a value there of 0.0879. So that would be how big the probability of getting exactly 3 is, about 8%. What if I wanted to use my formula? Well, I want to find the probability that X is equal to 3, and so I want to do, now N choose X, so N is 5, so I'm going to do 5 choose 3, because I'm trying to find the probability of 3, so X is 3. Multiply that by my probability of 0.25 to the power of 3 times 1 minus 0.25 to the power of N minus X, so N is equal to 5 minus 3. So let's just simplify this a little before I put it into my calculator. I want 5 choose 3 times 0.25 to the power of 3. Now 1 take away 0.25 is 0.75, so I'm going to do times 0.75, and 5 take away 3 is 2. So this is what I now want to enter into my calculator. So let's go to our run mode, and let me just wriggle this over here. So we are going to do, now we've got to do this 5 choose 3 first. So I need to click on the options, and when I click on that option button, you'll see I've got more options that come across the bottom. I just need to go across, so I'm going to press F6, and then there's an option there for probability. So that's F3, so I'm going to click on F3. And you can see there's my NPR and NCR, and I want the NCR. So that's going to be F3. Now just before that, I'm going to move my cursor back. I need to do 5 in front of the C. So 5 choose 3, and then I need to multiply that by 0.25 to the power of 3 times 0.75 to the power of 2. And that will go ahead and calculate that as 0.0879. 0.0879, the same as we found on the tables. The third way is to use the graphics calculator, but use the binomial distribution. So I'm going to come into my stats menu here, and I'm going to go to the distributions, so that's F5, and I want the binomial, which is again another F5. Now BPD and BCD, BPD, that's if I want a single point, whereas the C stands for cumulative, if I want to know the probability of being above some value or below some value, so I want to accumulate them. Here I just want the value of 3, so I'm going to choose BPD. So I need to make sure that my data says variable. If it doesn't, so the default, if I reset, often says list here, and so I just need to change that by pressing F2, and that changes it to variable. Now the X value, I want to find the probability of getting 3 bones that are foot bones. my number of trials is 5, and my P, my probability of success, is 0.25. And I'm going to solve that, and there is exactly that same probability, 0.0879 rounded. So there are 3 methods that you could use to find this probability. Let's have a look now at a second example. So only 10% of the cells in the human body are of human origin. The rest are mostly bacteria and fungi. So if 10 cells are selected at random, what's the probability that more than 2 are human? So I've got this 10% and I've got this 10, and then I've got a probability that I want of more than 2. So 10%, well, that's my probability of success, 0.1. And I've got 10 cells, so that's my number of trials, is 10. Now I've got the little graph down below for that particular distribution, and I want to know what's the probability that more than 2 are human. So when it says more than, that doesn't include 2. So more than 2 would be the same as greater than or equal to 3. So in terms of my diagram, I want to know the chance of 3 and 4 and 5 and 6. I need to combine those together. I need to find that cumulative number. Now, an alternative that might be useful for us is that all of that tail added together plus the other side, the whole distribution together, has to add up to 1. So if I subtract from that this part here, I would get the same answer. So 1 minus the probability of x less than or equal to 2, which I could then write as probability that x is equal to 2 plus the probability x is equal to 1 plus the probability x is equal to 0. So if I was to add those 3 together and subtract them from 1, I'd get the same answer. So depending on how many values we've got, we might find it easy to add or subtract. So let's go to our options, and our options are, we could go to the table. So we've got a probability, let me just write up top, probability of success of 0.1, and the number of trials is 10. So I can go on my table and I can go, right, there's my 0.1 probability. N is 10, that's this bottom piece down there. And you can see in that column I've got a bunch of numbers. So I want the probability that x is greater than or equal to 3. So that means I would need to add up all these values there, or I could do 1 minus the values above it. And that will give us our answer, which when I add that up becomes 0.0702. Now if I was going to use the formula for this, I would need to use the 1 minus, because it's probably going to be less calculations. So I'd do 1 minus probability of 0 and 1 and 2. So then I would need, for each of those probabilities, I would need to use our formula here. So I would go, n in this case is 10, so 10 choose, and I'll start with 0. Then I do probability, which is 0.1 to the power of x, which I'm choosing 0, times 1 minus 0.1 to the power of 10 minus 0. Then I'd have to do that again for each of them, and you can see doing it that way is going to take a moment or two, but we can do it that way. And particularly if we've got a probability that's not on the table, then that would be what we would have to do, unless we go to our calculator. So let's go to our calculator. So let me jump back out to here. So I'm in fact, let me go back out. So that was with BPD. So that was an individual one. But remember I said there's the cumulative one as well. Let's have a look at that. So if I go distributions, then binomial, F5, and this time I'm going to choose BCD, the cumulative. And so when we do the cumulative always gives us the left-hand tail of the graph. So when I look at the graph here, it's going to give us that left-hand side. So the calculator's going to find this area for us. And we've just got to know that. So where was I? The x we're looking for, it was greater than or equal to 3 or less than or equal to 2. So I'm going to go for 2. My number of trials is 10 and my probability of success is 0.1. And that gives me a value there of 0.9298. So I'm going to use that and say the probability that x is greater than or equal to 3 is equal to 1 minus the probability x is less than or equal to 2. So 1 minus that value of 0.98, where was it? 98 something, 9298. Gosh, I can't remember it well. 9298. And that will give us that same answer of 0.0702. So 3 different methods to be able to get through to the answer. Thanks very much for watching.